Hello students, it's Mr. Win here, and today we're going to learn about tangents, central angle and arc measures, and arc length of a circle. So let's define tangent real quick. Tangent is a line that touches the circle at exactly one point. Okay, so this point of tangency right here, point K, is the tangent point. Okay. The points that are inside the circle are known as the interior points. The center of the circle is point O right here, and any point that are on the outside of the circle are the exterior points. And the point that is like point of tangency, that point K, you notice how this point is on the circle because the tangent touches that point, right? We're going to learn about some theorems about this tangent, okay? First one is called the radius tangent theorem. Um, it says that the tangent, any tangent that touches the circle, is 90 degrees to the radius. Okay, so it touches the circle and it forms a 90-degree angle with the radius. Now, this does give us an implication, right? So anytime you have a right angle somewhere, that means you could draw a right triangle and use the Pythagorean theorem to solve those problems. Okay. The second theorem is called the two tangent theorem. I didn't make up these names, guys. This theorem says if two tangent comes from the same external point, then the segments are equal to each other. Okay, so you can see here this tangent segment comes from this point, and this tangent segment over here comes from this point, so they both come from the same point, and they touch the circle, and this one touched the circle right at one point. Well, the theorem says if that's the case, then these two segments have to be equal to each other. Okay, I call this the flashlight theory because here's your flashlight, and you say you shine your flashlight on a wall, and so the distance on each of those, the side of your light, is equal to each other. So that's the way. I mean, if you can try this if you want to. You can take a flashlight and shine it directly at 90 degree on a wall or something. As you can see that the two cones, so to say, are pretty symmetrical. So I call them the flashlight theory. Anyway, you call it whatever you want, but the two segments are equal to each other. Okay. Anyway, like I mentioned before, the Pythagorean theorem could be used in these two cases to solve problems. Okay, so keep that in mind. Here's one example about that flashlight theorem. I'm going to refer it from now on, flashlight theorem. The two tangents are equal to each other, so you can see these two red segments here are tangent, and they both come from point P, which means these two segments are the same. So in order to solve for x and find segment L, we have to set up an equation that says P or segment L equal to, or segment PO, P P sub 0 and then P sub 1. Anyway, these two segments are the same, so we're going to set them equal to each other. And we solve for x by adding 3 to the other side and subtracting x, right? So x equals to 9. That's a pretty simple equation there. Let's look at another example. Oh, I haven't found L yet. So substitute substitute 9 in to find L. So I made a mistake that a lot of people do. It's after we solve for X, we tend to forget what the question is asking for. So guys, don't do that. Okay, always go back to the question and answer the question. So yeah, I just made that mistake. Anyway, next one. So here we have a circle at center C. So circle C, it doesn't look like it's exactly at the center, but I'll take the word for it because it says right here, refer to circle C. That means the center's at C, right? With tangent AB, we have to find the value of x. Well, If you look at this carefully, now notice, remember the tangent. If this is a tangent, that has to be a 90 degree right here. So angle CBA has to be 90 degree, which makes this triangle ABC a right triangle, right? That means I could use Pythagorean theorem that says 5 square plus 12 square, and then take the square root of that to give me 13. But then to find x, notice x is the external piece. X is not 13. X is only a piece of that, right? The whole thing, CA, is 13. Well, we know that the radius is 5, so this must also be 5, right? The circle is drawn very, very deceivingly. So, but take my word for it. If C is the center, then the distance from C to B and the distance from C to this edge is equal, right? Because they're both radii. So if the whole thing is 13 and this radius is 5, that means the external piece must be 8. Okay. Next one. Oh, is this the same one that we just did? Okay, the two pieces are equal to each other, so we set them equal, and then we solve. So add 3 to 27 to get 30, and then divided by 2 to get 15. So x is 15. And yeah, that was a simple one. Next one. Okay, this one looks kind of a little crazy. But notice all of these. So here's a circle. Look at all these. So look at point C. Point C has two segments that come and touch the circle, right? So CD is a tangent. CB is a tangent. And then if you look at point A, AB is a tangent, and then AH is a tangent, right? So anytime you have a point that shines on like a flashlight, then you know that these pieces are equal to each other. So AB would equal to AH. So this AH segment would be also equal to 3. So I'm going to fill out all the missing segments real quick in order for me to find the perimeter. So to find perimeter, I got to add all of these things up, right? So I have to know all of these missing values that are here, okay? So I need to know what AH is, I need to know what GF is, I need to know what FE is, and then CD, okay? But it's easy. They're congruent, okay? AC is 5. CE is 5 also. How do I know that? Because CD has to be 2. Because CD is equal to CB, because they're both tangents that come from the same point. Well, after I find all of those values, EF right here is 3 also. GF is 1, so 1 plus 3. That's where I got my 4 here. And then for GA, I have a 1 here. And then, of course, this AH is 3 because it's the same as this one over here. So 1 plus 3 is 4 again. And then I add 5, 5, 4, 4 together. I get 18. The perimeter of this weird looking polygon on the outside of this circle is 18 unit long. Okay. Next one. Here's another example. Line NP. So line NP, this line right here, is tangent to circle M. Okay, so this line is tangent to this circle M, and that's MN is the radius. What is the measure of angle M? Okay, well, we know that this is 90 degree, so this angle M must make up the other 90 degree with angle P. So that's easy. All I have to do is subtract 90 from 20 from 90, right? Because angle M and angle P has to make up the other 90 because the whole thing is 180. So subtract 20, angle M is 70 degrees. That one wasn't too bad. Next, we're going to talk about central angle and the arcs that make up the central angle. Okay, central angle is the angle that has a vertex in the center of the circle, right? And this happens when you have two radii meet, right? Two radii. Anyway, and when this happens, it separates the circle into two arcs, okay? The smaller arc is called the minor arc. And the minor arc is usually less than half of a circle, which is a semicircle. So that's 180 degrees. So a minor arc is less than 180 degrees. The major arc, of course, is the bigger half of the circle. and that's bigger than 180. Okay, now the minor arc and major arc, how do we distinguish when we read a problem? Well, the minor arc, uh, of course, it's less than 180, but we use only two letters to name a minor arc. Okay, and that's how we distinguish between the two. The major arc, we use three letters to indicate. Okay, so every time you see a major arc, if it's not specific, then go with three letters. Okay, to make sure people don't get confused, because on a circle you can go either clockwise or counterclockwise, right? So we have to be careful when we name these arcs. Well, what about 180? What do we call that? We call that the semicircle. Okay, we call that the semicircle. All right, and we know there's a theorem, but it's not. We don't. I mean, I don't know if we actually prove this, but it says that the sum of the measures of all the central angles in a circle is 360 degrees. Okay, so all of the angles inside a circle is 360. Okay, and the arcs um, are measured by the central angles. Well, so what does that mean? It means the intercepted arc right here, UF, is equal to the central angle, because that's how we measure the arc. We use the central angle of that arc. Okay, so according to this problem, we have the semicircle here, um, which is 180 degrees, and then we have this central angle, which is 20 degrees. So UF, arc UF, is 20 degree. Okay, so what's the rest of this? What's arc FN? Arc FN would be whatever that's left from 180, so which is 160, right? So let's name some of these things, so that way we get familiar with them, right? Can you name all the minor arcs, all the arcs that are less than 180? Well, the most obvious one is UF. UF is only 20 degrees, so that's a minor arc, right? And then, of course, the other minor arc is FN, because that's less than 180 as well, right? So UF and FN. What is the measure of Fn? I think I mentioned that already. It's 160, because it's 180 minus 20. And then the major arc, there should be an S there, because I could get two of these, right? One of them goes, I could start from F, and then I go all the way to N. That's bigger than 180, right? So F, U, N. Remember, we have to use three letters to name these things. I could go F, U, N. That's one big major arc, right? And then I could actually name another one, I think. I could name F N U. If I go all the way that way, I can go F and then counterclockwise all the way to U. So I can name F N U, another major arc, right? So those are my two major arcs. I think I misspelled the arc. I was supposed to have an S there, because we have two of them, right? We can name two of them. All right, let's do another example. In circle E, we have angle AEN. AEN, this angle is 18, so we know the arc is going to be 18 degrees. We have JN is the diameter. Okay, so if this is diameter, then this half is 180 and this half is 180, okay? Angle JES is 90 degree. JES is 90. Oh, so that's nice. If JES is 90, then the other half must be 90, because this whole thing is 180. All right, let's fill that in. Okay, 90, 90, 18. Okay, so what is the question asking? It's asking us to find the measure of arc AN. Well, that's 18. We already did that. That's 18. Okay, because it's the same as the central angle. What about arc JA? Arc JA. Okay, so okay, remember this half is 180, and this is already 18. So arc JA must be 180 minus 18. So that's 162. So 162 degrees. And then arc JAS, that's the major arc, okay? JAS. So I go J and then A and then S, okay? So that's why naming them are so important. If I just say JS only, people would assume I just go JS this way. right? I don't go this way, major arc. That's why naming them with 3 letters is critical, okay, or crucial. So the major arc, let's say 180 plus 90 is 270, or I could do 360 minus 90. Either way, you get 270. You can do 180 plus 90, go all the way that way, or you can take 360, which is the whole circle, and take away JS to give you JAS. Another way to name this is JNS. You can name that major arc JNS as well. Anyway, so you could do it either way. Aye, one more problem. Ooh, this one has all the variables in them. Okay, but no problem. So we have these 4 arcs, and we know the total is 360. So all we have to do is add them all up and set it equal to 360 and solve the equation, right? So we're going to add up the first arc, 3x plus 15, and then plus x, and then plus 4x, and then plus 2x plus 15, and all of that equals to the circle, which is 360. Then next, we're going to combine like terms. So count how many x's you got here. 3, 4, 8, 10. 10x plus 30, okay, equal 360. If you're good at algebra 1, you can solve this in no time, right? So subtract 30 divided by 10. So x is 33. Now, what I'm going to do to answer these questions, I have to substitute the 33 back in here, right? So for the first arc, AOB, AOB is the first one they asked me. That's 33 degrees because that's just x. So, and then the second one, I multiply by 4. So I take 33 and I multiply by 4. I think I got the correct answer, 132. You can double check me on that. And then the next one, I substitute 33 in. That would be 66. And then I add 15 to that. And I think that's 81. Yeah. And then the other one, I plug in 33. So 33 times 3 is 99 plus 15, 114. Okay, so, right? 99, 99 plus 15, 114. Yeah. Okay. So now, if you don't trust yourself like me, I doubt myself so much all the time. You can add all of these up and make sure that equals to 360. Okay. So fill in your answers and move on. Last thing we're going to talk today about is the arc length. Now, notice the arc length. Please, please, please make the distinction. Arc itself is measured in degrees. That's how big the angle is, okay? Arc length is not measured in degree, it's measured in distance, right? So arc length is how long the little piece of that curve is, right? So we're talking about arc length of AB, you're talking about like how long do you have to walk from point A to point B on this piece on this circle. So imagine this is your pizza, right? So arc length is how long is this crust from here to here. Okay, so that's arc length. And how do we find it? Well, there's a formula. And yes, you don't have to memorize this formula. You can use this formula as a reference whenever you're working with arc length, right? So what is it saying? It says take the central angle divided by the whole circle, which is 360. So the piece of the pizza times the whole circumference. So times the whole distance around, right? So it says right here, take the central angle divided by 360 multiplied by the circumference. Well, the circumference is 2 pi r, which means in order to find arc length, you have to have the radius, okay, and the central angle. So you got to have 2 pieces of information, the central angle and the radius, in order to find arc length. So let's do this one. So to find the length of this arc AB, we do 30 divided by 60 and then times 2 times 3.14. I'm using 3.14 as pi here. You could use the whole pi if you want. The whole pi. We only want piece of the pi. Times 7. I'm such a dork. So 7 is the radius, right? So if you type all of this into your calculator fairly quickly, it's going to give you an approximation of 3.663, and you can round that to whatever the direction tells you to round it to. Okay. So arc length, you need two pieces of information. You need the central angle and the radius. Okay, there's another way to find arc length in radians, but we're not talking about radian yet. It's a lot easier actually. Okay, one more example. Here we're given a central angle of 50 degrees and the radius of 7 centimeter. So to find arc length of CD, we're going to do the same thing, right? The formula is the central angle divided by 360 times 2 pi r. And then we substitute that in. 50 divided by 360 times 2 pi and then times 7. Type that into your calculator. It should be around 6.11. Well, that is it for us today, guys. Thank you for watching, and I will see you guys in the next videos. Please subscribe to my channel for more math tutorials videos.